let's discuss special right triangles. So we will have two types of special right triangles. We're going to begin with the 45, 45, 90. Now, if you notice, these are degree measures. So if we say a 45, 45, 90, that's a triangle, which is a special type of right triangle because of the one right angle. The two sides that are not the hypotenuse, those are generally called the legs. Those are equal in length. And then the angles that are not a right angle are all also equal to each other, which are 45 degrees. Okay, so we have two angles that are 45 degrees, two sides that are equal, a 90-degree angle, and then a longer side that's called the hypotenuse. Now we're going to show in this image how a 45, 45, 90 triangle has a special relationship with the square. All right, so if we recall, a square is a quadrilateral. It's also a rectangle that has four equal side lengths. We're going to put in these angle measures. All right, so we know that we have a square. Now, I want to also discuss what we're looking at here. And I'm going to use this to kind of show just for a second. I'm going to divide this square into triangles. So now we have two triangles. Those two triangles contain a right angle, and the way that I've split this square, I've split it so that this is a diagonal, and that gives me 45-degree angles on each side. And in my image, I now have two triangles that are 45, 45, 90. And because I started with a square, we have these side lengths for each triangle that are the same measure. So if you're trying to figure out how do we know that if it's a 45, 45, 90, it has to have two equal sides, that's because a 45, 45, 90 can be made by splitting a square diagonally. Now, let's talk about also what we know as far as ratios with those side lengths. So I'm going to go back up here. And over here, on the right-hand side. So if I want to write a ratio that would describe the relationship between the lengths of the legs of a 45, 45, 90, and its hypotenuse. So the leg length, remember the legs are the same, so the ratio of the leg length to the other leg length to the hypotenuse is equivalent to this: 1 to 1 to the square root 2. Now that's the reduced ratio form. We know this because we could go in here and we could label this as a side length of 1, and I could solve for that missing side, and that missing side length is going to be the square root of 2. Okay, so this ratio, because we have three values here, we have three side lengths, is going to be something we're going to have to put to memory. It's a ratio of the leg to the second leg to the hypotenuse side. Now let's see how that ratio would help us solve a word problem. Okay, so the length of the hypotenuse of a 45, 45, 90 triangle is 6 meters. And I want to know the length of the legs of that triangle. So let's draw a picture of what we have first, and then I'm going to draw also our 45, 45, 90. Okay. So we'll imagine that we have 45 degrees here. Okay. Hypotenuse is the side that's opposite your right angle. And we're trying to find these lengths. Now, remember, what we know is, and I'm going to draw this figure first, and then in the next one we won't worry about drawing, but I want to show you where I'm getting the numbers. All right, so if it's a 45, 45, 90, I'm going to leave that because I don't like the way that looks. So if these are 45 degrees, then your ratio is 1, 1, square root of 2. Now, I can use these two triangles because they are similar to each other. This is a smaller version of this one. And I can form ratios. If we want to use x's here, we can use x's. If we want to use question marks, I'm okay with either one. But let's form a ratio. So I'm going to say that question mark side corresponds to the side length of 1. And then the 6 hypotenuse side on the larger triangle corresponds to square root of 2. Now, we're going to approach this in the same way. We're going to multiply or clear the fractions. So multiplying by 1, that's pretty easy. Doesn't change anything. But now I'm going to multiply by square root of 2. So question mark is equal to 6 divided by square root of 2. Okay, now let's do a little bit of review here because it's probably been a while since we've all done this. In this format, if I have a square root of a number on the bottom of a fraction, that is considered not simplified. So we have to do something called rationalizing. It looks harder than it is. So let's talk about what rationalizing means. So I'm going to go over here to this left column. So I've got this fraction that is not simplified. To simplify that fraction, I'm going to multiply by whatever my denominator value is. So I'm going to multiply by the square root of 2. And again, it's going to look worse than this is, okay? So remember, when I'm multiplying two fractions, the numerators are multiplied to each other. Since this is a whole number and this is something with a radical, I just multiply them like this. I cannot put the 6 times 2 and make 12. Now when I multiply two radicals, that's a little bit different. I can multiply 2 times 2 and get 4. Now the reason that's helpful is because 4 is a perfect square. The square root of 4 is 2. Now at this point, if your numbers reduce, meaning the ones that are not under a radical, then I can reduce. I can't cancel 2 with 2, but I can say 6 divided by 2 is 3. So the length of question mark, or the side lengths, is 3 square root of 2 meters. Now that would be a decimal if we put it in a calculator. We're not going to worry about that right now. I just wanted to show you how to do that. So we'd actually, if we wanted the decimal length, find the square root of 2 and multiply it by 3. Okay. Let's look at another example. So I want to do a few examples here so you can see what this looks like. The bases on a softball field are 90 feet apart. So let's mark that in our picture. 90. Okay. Now, if you notice, that softball diamond, is what we call it a lot of times, is rotated and it's a square, right? It was originally a square because we have all 4 sides equal. So that also tells me about these angle measures, right? And I'm putting those in. Now the question is asking to find the distance from home plate to second base. So if I use my ratios, which we had just talked about, I can solve this. So what I'm going to do, and again, my teaching tip here, biggest one, draw the triangles you need from your image because a lot of times that image is going to look a little bit harder. And then we'll draw what we call our reference triangle. So let me remind you, the reference triangle is the one that has our lowest ratio. So I'm going to go ahead and put it in. 1, 1, square root of 2. Now I can choose either this left hand or the right hand, whichever side of those right triangles we want. And I know that I have 90 degrees on each of the legs, and I know the missing side is the hypotenuse side. So I can say 90 over 1 is equal to question mark over the square root of 2. And again, remember we solved this by multiplying by the denominators. A lot of times we call it cross multiplying. It's also clearing the fractions. Okay, now this one does have a square root of 2, but notice it's not like that last example. We don't have to divide by the square root of 2. So this is 90 multiplied by the square root of 2, it's question mark. Now that's feet. If we go to a calculator, that's about 127 feet. I think is if I round that. So 127.3 feet. So roughly, I'm going to put estimated. Okay. Now again, you're using this reference triangle that has our ratio of leg to hypotenuse, 1 to 1 to square root of 2. And I'm going to leave this one, this example for you. Now that was the triangle, like I said, that was the 45, 45, 90. I feel like it's a little bit easier because you have two legs that are the same length. The second triangle is a special right triangle called a 30, 60, 90. So again, it's still a special right triangle. That doesn't change. The difference here is, since we have a 30-degree angle and a 60-degree angle, we don't have equal sides. All right, so here are some things that we know. The legs are different. One is longer, one is shorter. So the longest leg or longest side, that's not the hypotenuse. So leg means not hypotenuse. The longest leg is the square root of 3 times longer than the shortest leg. And the hypotenuse is twice as long as the shortest leg. And then the angles, again, they're 30 and 60. Okay. Now, teaching hint, teaching tip. Your longest side is going to be your hypotenuse. You're going to be using 2 as a reference for the hypotenuse. Most of the time, your students will think that the square root of 3 is larger than 2. It is not. Just remind yourself so that you can go through this with them and say, don't forget, the hypotenuse is going to be a reference of 2, so it's going to be longer. Let's draw so you can see an example. And I'm going to make one of the sides definitely longer than the other, so you can tell. Okay, so my right angle is going to be over here. Then I need a 30-degree angle and a 60-degree angle. So the longer side has to be across from the 60-degree angle. So the 60 is here, longer side, 30 is here. All right. So in this one, this would be 1 square root of 3, 2. All right. So remember our last one was 1, 1 square root of 2. So this one does look different. And it does seem like this should be longer because it has a 3. But the square root of 3 is this number that's smaller than 2. Okay, now we're going to show this special relationship with the equilateral triangle. So remember last time we took a square and showed the special relationship. So what I'm going to do here is I'm going to split this triangle into 2 smaller triangles. But first, actually, let's do this first. If it's equilateral, that means I have 3 60-degree angles and all of these sides are the same. Now, if I choose to split this, to move that over so it's in the center. There we go, because that's important to us. What happens is I now have a short leg. Oh, let's fix that. A shorter leg here, because this would be 30 degrees. So the opposite side. And then I have a hypotenuse here, because I'm forming a right angle. And then I'm going to call this the longer leg, because it's opposite the 60 degree. So I've taken something that was equilateral, I've drawn my dotted line, bisecting an angle and a side, and now I have the two smaller ones. Okay, so let's do some practice with these here. Okay, so I want to determine the x in this figure, and it says to use properties of the 30, 60, 90. So since this one's already drawn in this orientation, what I'm going to do is I'm going to draw my reference triangle in a similar way, meaning I'm going to use 30 and 60 in similar positions. Okay, now remember, the side that's opposite the 30 is your 1, or your short leg. The side that's opposite your 60 is your square root of 3, or your long leg, and your hypotenuse is 2. So if I can draw the reference triangle, again, that's my biggest teaching tip here, is use your reference triangles, then I can set up my proportions, because these are going to be two similar triangles that have proportional sides. Let's see, so I can say 12 over 1. All right, so this would be our short side on each one. That has to be equivalent to the ratio of the hypotenuse sides. So x and 2. Now this one looks so much better just because we don't have the square root values in there. So I'm going to multiply by 1 on each triangle, or excuse me, ratio. And then I'm going to multiply by 2. I didn't have length measurements of feet, inches, or centimeters, so I'm just going to say x is 24. And that's how you would find that length. Okay. Now, let's go through, and it says find the lengths of the other two sides if the hypotenuse is 8 and one of the angles is 30. So a similar question. Alright, I'm going to draw us a triangle in. I'm going to make one side definitely the long side. So 60 is here, 30 is here. The hypotenuse is 8. And then we know the other angle. So if we're trying to find, this is our short leg, long leg, then what we need is a reference triangle. I'm going to draw it to the side. And if you draw it in the same orientation, that will make your life much easier. Okay, short leg is 1, long leg is square root of 3, hypotenuse is 2. So again, I can use with this reference triangle to set up my proportions. So short leg over 1, and then 8 over 2. And I could say long leg over square root of 3. Let's make sure you can see that. Equals 8 over 2. And if I solve both of those proportions, I can find the lengths of those. And remember, if you need to rationalize, right, if we end up with a radical on the bottom, that's simplified by multiplication, okay? All right, so reference triangles, very, very helpful. Drawing them in the same orientation, super helpful.